This video is about vector and parametric equations of lines in R2. And so on this first slide, we're just going to recap. You already know a little bit about equations of lines. So if you're given 2 points, you can find the rise and you can find the run. This is going to allow you to find the slope, which lets you find the equation of the line in slope y-intercept form. Y equals mx plus b, point slope form, y minus y1, m times x minus x1, or you can write the equation of a line in standard form. So ax plus by plus c equals 0, where a, b, and c are elements of integers and a is greater than 0. So these forms you already know. We're going to extend it today to 2 more forms, the vector form, which we'll do first, and then the parametric form. So let's look at the vector equation of a line. So if P is any point on the line, and you picture P as moving back and forth across that line, O, A, and P always form a triangle. Because AP, so this vector here along the line, is collinear with M, your direction vector, the vector AP is T, scalar multiple of M. That is going to allow you to get every combination of point on that line. So here is our vector equation, and here is a sample of what it looks like. I'm not going to spend too much time on this. This is the same vector equation that we learned about last year. So let's look at a summary, and then we'll move into parametric equations. So for the vector equation of a line in R2, A is a fixed point on the line, and it has a direction vector. P is any point on the line. So the vector equation of that line is xy equals a1, a2, your position vector, and then plus t, some parameter, times your direction vector. To find a parametric equation, this is where you write an equation for each of the coordinates. So here we've got modified vectored form, which is just really written out and expanded along here. And then now we're going to look at the summary of the parametric equations on the line. So A, still a fixed point on the line. M is your direction vector. This should be M2 here. And then P is any point on the line. So then our parametric equations are here. We have one equation for x, A1 plus T M1, y equals A2 plus T M2. T is a parameter that can represent any real number. So let's look at these equations in terms of a real example. So we have a line passing through the point 4, 3, and it has direction vector minus 7, 1. And what we want to do is sketch this line. So first, let's write our vector equation of the line. So we've got xy is equal to our point 4, 3 plus t times minus 7, 1 using our direction vector. So P and then our direction vector. Our parametric equations, really all we do is expand that. So we've got 4 minus 7t, and then we've got 3 plus 1t. So these are our parametric equations. That is new. Okay, so then what we're going to do is we're going to sketch the line. So the first thing that we need to do is let's draw our direction vector here. So we've got minus 7 and then 1. Here. Hopefully you have a ruler with you to draw that. So here is this is our direction vector. Now we're going to add in our point. So we've got 4, 3. this is our point. So now really, what you can do if you have a ruler, okay, is you can line it up with your direction vector and then shift it up so that it goes through your point. And when you do that, it should go right through. Your other strategy is that you know to get to your next point, you have to go left 7. 1, 2, 3, 4, 5, 6, 7. And then up 1. That's what your direction vector tells you. Your run is -7 and your rise is 1. Then what you're going to do with your ruler, hopefully it doesn't work as well on my iPad as I'd like it to, is you're going to draw a line with a ruler that goes straight through those 2 points. Then you've got your point 4, 3 and your direction vector -7, 1. Let's look at another example. So a line passing through the points A, -1/2, -3, and B, 3/4, 1/2. Determine a direction vector for this line and write it using integer components. Okay, no problem. Let's start by finding the vector AB. So our vector AB is OB minus OA. So in order to do that, we're going to take our points here. So we've got 3/4 and 1/4 minus 1/2 minus 1/3. Putting those together is going to allow us to get 3/4 minus 1/2 and then 1/2 plus 3. When we simplify that, we get a vector that has 2 fractional components, 1/4 and 7/2. This is going to represent our direction vector M. Now, if you remember, we can change a vector just by multiplying by a scalar, and we still get a vector that's in the same direction. So let's multiply this vector by 4, and then we get 1, 14. What we can do now is use that direction vector to answer the questions. So therefore, the direction vector of this line is M equals 114. Or really could be any scalar multiple. You could have 228, okay, or any other scalar multiple. Okay, let's look at one more example. Determine the vector and parametric equations of a line passing through the point A with direction vector M equals -3, 3. Okay, so that's our first part. So let's put that as part A. And then part B, we're going to check and see if some points lie on the line. So let's do our equations first. So to do our equations, we're going to start off by setting up our vector equation. So xy equals our position vector or our point, 1, 4, plus t times our direction vector. Now, we can expand this, so let's label it. So vector equation. Now, let's expand it and write an equation for each component for our parametric equations. So here, these are our parametric equations. You do need to have both, one for each component. Okay. Now that we have those two equations, this is A, we're going to look at B. So we're going to test those 2 points. So what we need to do is to check and see if those points satisfy the conditions. So probably the easiest way to do it is to sub it in to your parametric equations because you already have them split up. So let's sub into, so we're going to sub into parametric equation. And really we're just checking to see if t comes up as the same value in both. So our first one, minus 21 equals 1 minus 3t. Rearranging that is going to let us know that for x, t is equal to 22 over 3. Now we're going to do the same thing for y. So 23 equals 4 plus 3t. And when you rearrange that, you get t equals 19 over 3. So since t is inconsistent, the solution is not the same. Q is not on the line. Okay. Now we're going to do the same thing. So that was Q. Let's check R. Minus 29, 34. We're going to do the same approach. So minus 29 equals 1 minus 3t. Rearranging this allows us to find that t equals 10. And then if we do the same thing for our y equation, we also get t equals 10. So since t is consistent, it's the same in both cases, R is on the line. Okay, give those homework questions a try.